Hi, and welcome to the Class 24 video. The previous 3 videos were just about translating sentences from English to our symbolic language SL. And that was simply a matter of replacing the atomic statements with individual letters, sentence letters A, B, and C, and then hooking them up with parentheses and a group of symbols we were calling the sentential connectives. The sentential connectives included the negation, which was the little squiggly line, the conjunction, the disjunction, the conditional, and the biconditional. So in this video, I want to give you some concepts for understanding what it is we're doing when we make these translations and why it's important and what it is we learn about the underlying logical structure of the English language through these translations and through the logic of SL. And what we're going to be learning about is ultimately a bit of syntax. We're going to be learning the syntax for our language SL, which will help us understand the role of syntax in logic in general. So here's the video. Once again, it's an older video. The sound quality is a little off, but it covers all the right material. All right. The previous video gave you some basic direction on how to translate some English sentences into our symbolic language SL. And that was simply a matter of replacing atomic statements with individual letters, A, B, C, and then hooking them up with parentheses and a group of symbols we were calling sentential connectives. That includes the negation, that is the little squiggly line, the conditional, the biconditional, the conjunction, and the disjunction. In this video, I want to give you some concepts for understanding what it is we're doing when we make these translations and why it's important, and what we can learn about the structure of language from this. So one interesting discovery is that these class of words and or etc. Actually have an interesting property in common. They are all truth functional. They are defined by the way they transform the sentences they connect. So if you have a sentence A or B, A and B have truth values, and then the whole sentence, A or B, is a simple function on those original truth values. So, consider 2 sentences. Grass is green, which is true, and I am the Pope, which is false. You put those together with an or, and you get this statement, either grass is green or I am the Pope. And as it turns out, that whole statement is true because one side of it is true. Grass is green, and that makes the whole statement true. So the or turns out to be a function on these 2 inputs. And it says that if one of the inputs is a T, the output is also a T. So now think about 2 sentence letters again, A and B. There are actually 4 possible combinations of truth values that we are dealing with here. For instance, the A, we know, can be true or false. Suppose A is true. Then we know B can be true or false. Similarly, if A is false, B can be true or false. And so that gives us 4 possibilities. And we'll just fill out the line here, right? So there are 4 possible inputs for any sentence with a sentential connective that's hooking up 2 other sentences. And what we say is that a sentence like A and B performs a function on these other 2 sentences. So we can just map the 4 possibilities over like that, And then we say the statement A and B is going to be true if both of those inputs are true, because it's saying A and B. A is true and B is true. But if B is false, the whole thing is false. If A is false, the whole thing is false. If both are false, the whole thing is false. All right, let's go back to the word or. We said last time that the word or in English is ambiguous between what we call the inclusive or and the exclusive or. That is, or could mean A or B or both, or it could mean A or B, but not both. And this is why when someone says you can do X or Y, you can always ask the question, well, can I do both? And it's an open question because the English is ambiguous. The disjunction in logic is not ambiguous because we don't like ambiguity in logic. We're going to be using the inclusive or. It's going to mean this or that or both. And that will be reflected in the table for this. Again, you see our 4 possible inputs, and when they combine, there's only one way for the disjunction to be false, and that's if both inputs are false. As an aside, you can try and figure out what the characteristic truth table for the exclusive or would be. But let's set that aside. So let's just look at this truth table again. We've got 4 possibilities. If both A and B are true, then the or statement has to be true because it's the inclusive or. If B is false, that's fine as long as A is still true, because then the statement A or B is true. Same is true if A is false and B is true. The only time the whole thing is false is when both sides are false. So now we have 2 tables. We call these truth tables, and they characterize the meaning of the sentential connectives. In this case, the connective for and the connective for or. Now let's take a look at the table for the connective if-then, the implication. Again, there are 4 possibilities. But as with the or, the if-then statements in English are ambiguous. So it's pretty clear. So 2 cases, they're not unambiguous. If I assert A implies B, and A is true and B is true, then obviously I am correct in saying that A implies B. Because I said A would lead to B, you got your A, you get your B. On the other hand, if I say A leads to B, and we get an A, and we don't get a B, then obviously I am incorrect. A implies B is false if A is true and B is false. But what about the situation where the antecedent, the left-hand side, is false? Ordinary English is actually ambiguous about this. If I say, if it is raining, you should bring an umbrella, I'm not really saying anything about what happens if it's not raining. You might infer that I think you shouldn't take an umbrella if it's not raining, but maybe I think you also might want a sun umbrella. I don't know. You'd need to ask me another question to clarify my if-then statement if the first part of it, the if part, isn't true. So to resolve this ambiguity in logic, we simply say that the conditional statement is true whenever the antecedent is false. And that's actually a fairly arbitrary decision on our part, but we need a connective actually that has this set of truth values, and doing it any other way would just wind up being useless or redundant. So now we have 3 connectives. The last connective that connects 2 things together is the biconditional, the double-headed arrow, if and only if. And what this says is that the 2 sides have to match. So if both sides are true, the whole thing is true. But if the 2 sides don't match, it's false. And then on the final line, again, when both sides match because they're both false, the whole thing is true. Those are the 4 truth tables for the connectives that actually connect 2 things. We also have the negation, which is like a one-place connective. It doesn't actually connect anything, but we still call it a connective. And for this one, we don't need a B. It's just got one place. So we just have one input, and that input can be true or false, and the negation flips it around. So here we go. We have 5 possible truth tables. This characterizes the meaning of the 5 sentential connectives. You are going to need to know these tables by heart. You need to be able, because you're going to be able, you need to answer questions where it's like you're fluent in a language and you don't have to look everything up in the dictionary. You can just do it. You may have noticed that I was using a different font for A and B, and you may have not paid any attention to it because who cares about fonts? Actually, in this case, it makes a difference. And this is because we are, in order to create a new language like SL, we actually need a 3rd language, which we're calling the meta-language. The meta-language is like scaffolding around a building. So the new language we're trying to create is SL. SL has variables in it. These are the sentence letters. In order to build SL, we need this scaffolding, which is called the meta-language. The meta-language consists of ordinary English plus a few additional special symbols. These special symbols aren't a part of SL, but they help us make SL. And meta variables are important here. So you can think of 2 layers of variables. The sentence letters A, B, C, D, etc. in red are variables that can represent any English sentence. So the letter B can represent my dog has fleas, the cat sat on the mat, the murder of logician Richard Montague was never solved, or elves live in tunnels under Stocker Center. I'll give you a hint. At least one of these statements is true. So that's what B can stand for. Now consider the letter script B in blue. This can stand for any sentence in our object language SL. So it could mean A, it could be B, it could be C or D, it could be C and D, it could be not D implies E or A if and only if Q. It could be anything. It could be any sentence, not just an individual sentence letter. It could stand for much longer sentences. The fact that we've got meta variables in the meta language allows us to say things like any sentence of the form script A and not script A is a contradiction. So that's something that we're saying in our meta language, and it is about our object language, which is SL in red. This scaffolding that we're using to create SL actually allows us to define parts of SL extremely rigorously in a way that we would not be able to otherwise. So what we're actually going to be doing here is giving what we call a recursive definition. A recursive definition is a flexible way of defining terms where you start with a base class and then you use rules to expand on that base class. So technically, a recursive definition has 3 elements. It has a base class. Everything in the base class is defined as part of the thing you are defining. So we say, in the case of a sentence in SL, any individual sentence letter is in our base class and counts as a sentence in SL. You add to that base class rules for extending the base class, which says that anything that you can create by combining members of the base class in a certain way also counts as a sentence. And then finally you have a closure rule that says that only things in the extended base class fall under this definition. And this, again, is another illustration of the way that logicians think that the difference between if and only if is very important. And now we have a recursive definition that has both ifs and only ifs in it, so it is a solid definition. So our base class consists of the sentence letters A, B, C, D, etc. Then we've got these expansion rules. So for instance, if A is a sentence, then not A is a sentence. For any well-formed sentence in our language, if you put a little squiggle in front of it, you get a new sentence. And then you've got similar rules for the other connectives. What this means is that when you encounter a complicated sentence in SL, it has a structure in it that is based on how the sentence was constructed, how it was built up out of these basic parts. So you start with your basic parts, A, B, C, D, and E, right? And now we have rules that allow us to expand on these basic parts. So extension rule 1 says that if we add a not to the A, we still have a sentence. So not A is a sentence. It's a level 2 sentence. If level 1 is A, B, C, D, and E, level 2 has not A in it. It also has D implies E, because that's formed out of the things on level 1 using extension rule 2, which lets us put together D and E to get D implies E. Then we can put these two outputs together at a third level, and then we get not A or D implies E. And we know this is a sentence because it has been built up properly out of these underlying elements. So whenever we have a sentence like this, a big complicated sentence in our language, we can identify its parts based on how it was built up. So in this case, the or is the main connective because it was the last thing that we added when we were building this sentence up. The negation and the conditional are secondary connectives then. So we define a main connective as the last connective added when building a sentence recursively. We also want to talk about the scope of a connective. The scope of a connective is the part of a sentence modified by that connective. So these are the sentences that was actually the connective was applied to when you were building up the sentence recursively. So for the top sentence, the scope of the negation is A. For the second sentence, the scope of the negation is still A. But because of the parentheses, the third sentence has both A and B in the scope of the negation. So in the third sentence, the negation is the main connective because it was the last one added to the sentence when we were building it up recursively. And it has everything else in the sentence in its scope. Okay, one last bit of technical definitions, and then I'll let you go. In logic, it's important to distinguish between syntax and semantics. So I said that we were using our formal methods to obtain content neutrality. And when we do that, we are isolating just the syntax of the language. The syntax of the language is how we build up the language without considering any aspect of meaning at all. We don't think about whether something is true or false or whether it has any meaning. We just follow rules for using these symbols. Semantics is a bit of language and its structure, including truth and including meaning. So that includes truth and falsity. So, for instance, the computer that you are looking at now is a syntactic engine because what it does is it processes language. It doesn't understand what the words mean. It just moves the words according to symbols. You, on the other hand, are understanding these symbols semantically. You are understanding them with regard to meaning. All right, so that is the end of the content for week 3. We've learned to translate sentences into SL, and in this section I have given you some metalogical concepts for understanding the syntax, the structure of SL. If you look at the practice test, you'll see that you've got 2 kinds of questions on it. For some of them, you just need to know about, you need to know how to translate sentences into SL. For other questions, you'll need to know about the material talked about in this video. That is, ideas like syntax, semantics, meta-language, meta-variable, that sort of thing. Also, I can guarantee you that for the test, you will need to know the characteristic truth tables for the basic connectives.